As we go into radicals and talking about their connections to exponents, we're just going to take a step back and review over solving problems that have roots involved with them, and then also simplifying without a calculator things that have square roots. So first of all, we're going to solve over reals some problems. So let's start with a problem like this that we've done for a while. First one is 5x squared equal to 320. Now this one, you're going to start by dividing both sides by 5, so you get x squared equal to 64 when you divide by 5. And then your next step is to take the square root of both sides. The square root of 64 is just an 8, but the square root of x squared is the absolute value of x. Now we typically will skip this step because we know absolute value produces two answers, and so we'll list it as plus or minus 8 as our answer. Now a second problem we want to do, we're going to do this over reals. So for this one, we're going to go ahead and on this have x cubed minus 4 equals 212. We're going to solve this over reals, and later we'll solve it over complex numbers. So later we'll look at how you can get multiple answers. In fact, you'll get 3 answers when you do it over complex numbers. But here, if we just do it over the reals, we can take the step of going ahead and adding 4 to both sides. So you get x cubed equal to 216, you add 4. Now when you take the cube root of both sides, I'm going to write this a little differently. I'm going to write it, if you do the cube root of x cubed and the cube root of 216, you know that the cube root of x cubed is just going to be x, because this is like writing x cubed to the 1/3 power, and then you multiply these two exponents, you get x to the first as just an x. The cube root of 216, you might have our perfect cubes memorized. You're starting to get the hang of it during Algebra 2 as to what those perfect cubes are, and recognize that that is a 6. If you don't recognize that, what you can do is you can do a factor tree and look for things that can group together. So you could do 2 times 108, 2 times 54, 2 times 27, and that's 3 times 9, which is 3 times 3. So notice these 3 go together, that's 2 cubed. These 3 go together, that's 3 cubed. So when you take the cube root of that, you get a 2 times a 3, which is equal to 6. So you can do a factor tree to help you if you don't have it memorized that the cube root of 216 is just 6. Now, let's solve that exact same problem. This time we're going to do that over, we're going to do it with complex numbers. And I'm going to use factoring to do this one. We're going to end up with 3 answers to this one. So on this one, I want to get everything on one side, so I'm going to go ahead and subtract 212. So we get x cubed minus 216 equals 0. This is the difference of cubes. And if you recall our factoring pattern for the difference of cubes, it gives you a binomial times a trinomial. The binomial is, this is x cubed minus 6 cubed. So this first parentheses will just be the x minus 6, just drop the cubes. The next one will be x squared, you'll make it a plus. If this is a minus, that becomes a plus, and then just 6 times x. And then for the last one, it's always a plus, and then square the 6, and you get 36. So now we have 2 things that multiply together to equal 0. You set each of them equal to 0. X minus 6 equals 0. That gives us our real answer of x equals 6, just like this one. But this one, x squared plus 6x plus 36 equals 0. We're going to solve that using the quadratic formula with a equal 1, b equal to 6, and c equal to 36. So if we put those into the quadratic formula, what we'll get is x equals the opposite of b, which is negative 6, plus or minus the square root of b squared which is 36, minus 4 times 1 times 36, all over 2 times 1, which is a 2. Now when you do that, you go ahead and do the simplification underneath that square root, you're going to get negative 6 plus or minus, that's going to be a negative number, you're going to get negative 108 all over that 2, so you got to take the I out. Now you're looking for perfect squares that go into 108. A perfect square that goes into 108 is 36. So when I take that, I've got negative 6 plus or minus I times the square root of 36 times the square root. When you take out that 36, you're left with a 3, square root of 3, all over 2. And so my answer here will be, I'll have negative 6 plus or minus, this will be 6I square root of 3 all over 2. When I simplify it though, because I want to separate them, negative 6 over 2 is equal to negative 3 plus or minus 6 over 2 is going to be equal to 3. So we have 3 square roots of 3, and I like to have the I at the very end, not under the radical, but at the very end. And so this would be the answer to 2 of the roots along with this 1 root over here. So 3 roots to that, solved over complex numbers. So that's a little bit of review over solving using roots. Now let's go ahead and simplify we're going to simplify radicals, this without calculators. We're going to focus primarily on square roots and cube roots. So the first one I want to do is, let's say we want to do the square root of 162. Okay, you want to think about what perfect square goes into 162. Now you might remember 81 goes into it, but if you don't, you just do a factor tree. Just go ahead and separate it out to see what goes into it. And you might catch it pretty quickly, because if you did 162 and separate it, you have 2 times 81, oh, say, there's a perfect square. So you do square root of 81 times square root of 2. Square root of 81, we know that principal root is equal to 9. The square root of 2, we don't know. So if we're solving without a calculator, to get the exact form, it's just 9 square roots of 2 as an answer, because you can't simplify the square root of 2. So that is our exact answer that we figured out by finding a perfect square that goes into it. Let's do one more here. We're going to do the cube root of 500. Now, it has the same properties of this one. We want to look for a perfect cube that goes into 500. Now, if you're not sure what perfect cube goes into it, just do a factor tree. An easy one is 5 times 100. And then notice that 100, you say, oh, that's a perfect square. Well, we're looking for perfect cubes. 100 is not a perfect cube. So we separate that into 5 times 20. And then 20 is 5 times 4. Well, notice I've got 3 5s here. So 125 goes into 500. So I can make this as the cube root of 125 times the cube root of 4. So separate the 2 of them. Cube root of 125 is just equal to 5 times the cube root of 4, which we can't simplify. So that's our answer to that. So this was just to do a little bit of review of solving and simplifying problems that involve using radicals, whether it would be solving using radicals or simplifying, and just reminding ourselves of some of the rules that we use and some of the procedures we use to solve and simplify.